everybody, and welcome to an episode of Echo Live. My name is Anna, and of course, I'm coming to you from the Michigan Science Center's Echo Distance Learning Program. I can see some of our familiar and new faces already starting to pop up on our various platforms. Hello to our friends on YouTube. Hi, everyone who's joining on Facebook, and right here inside our Zoom meeting. If you haven't done so already, go ahead, introduce yourself in the chat feature like always. You can type in the comments or the chats to introduce yourself, to tell us a little bit about who you are and where you're watching from. But most importantly, you can use that chat feature in order to interact with us throughout the program. Now, we're going to be joined in just a few minutes by a special guest from Ford Motor Company. But I thought first we might introduce the content of today's episode of Echo Live. We're talking about a very new and exciting topic in engineering and in technology all around the world, but specifically right where we live, right here in Michigan. If you live in Michigan like I do, we are making advances in what we call autonomous vehicles. We're going to talk more about autonomous vehicles in just a little bit, right? But basically, when we're talking about autonomous vehicles, we're talking about robots and machines. Now, in past episodes of Echo Live, we've discussed simple and complex machines. We've talked a little bit about robots and what we can have them do to assist humans with various tasks. But in order for us to have robots or computers do jobs for humans, right, we have to be able to tell them what to do. We need to communicate with computers. Does anyone remember how we said humans are able to communicate with various types of machines or robots? We've talked about this a couple times on Echo, but if you can remember what we do to communicate with them, tell us in the chat. I'll give you a hint, right? This has to do with some sort of language, right? Now, robots like my R2-D2 remote control robot, he runs off of a remote control. So by pushing the various buttons here on the remote, we are able to ask R2-D2 to perform various tasks. But we don't always need something like a remote control, right? We have other ways of communicating with robots as well. Let's see, Evan from Texas tells us computer programming, right? Now, you might specifically remember that when we talked about computer programming, we mentioned that we are using code. We specifically learned a little bit about binary code, that language of ones and zeros, just like Michelle told us. Now, we can encode all sorts of messages or commands into lines of code and send them to our computers or robots, just like R2-D2. When you push a button on this remote, it activates a line of code inside the robot, but we can even interact with robots without steering them with some sort of remote. The more advanced robots get, right, we are now getting into the realm of autonomous vehicles and autonomous robots, ones that are able to think and make decisions based on their environment, right? So today we are going to be joined by a very special guest from Ford Motor Company who's working on the future of autonomous vehicles. This is Dr. Pandey. Dr. Pandey is going to join us right here in the meeting to talk to us about autonomous vehicles and specifically about one of their new humanoid robots called Digit. So hi, Dr. Pandey, how are you today?
Oh, I'm doing good. Thanks, Anna. That was a great introduction for the talk that I'm going to give, and I'm very excited to be part of this program. I love robots. I've been working on autonomous vehicle for almost a decade now, and Ford is doing some very exciting things and would love to share that with all the audience we have today.
So remember throughout the program that if you have questions for Dr. Pandey, you can type them in the chat feature. We'll save some time throughout the program and at the very end so that he can answer your questions about his job at Ford and about Digit, who we're about to meet in these upcoming videos.
All right. So if you can start the video, Anna. So I would like to introduce you to our new robots, which we have recently purchased from Agility Robotics, who has created these robots, these bipedal robots that can go to places and do things that typically the wheeled robots that you all probably are more familiar with cannot do. So as you can see, Digit is built out of very lightweight material and is capable of lifting actually almost 40 pounds. It can go up and down stairs, walk naturally through uneven terrain, and even react to things like being bumped without losing balance and falling over. It has that intelligence built into it. As humans, we take all these abilities to walk and climb stairs very for granted. But from an engineering point of view, this is a very challenging task. Making the robot walk, and that to walk more like humans, it's not an easy job, as you may imagine. And as you know, like most of the environment that is built around us, it's actually built for humans to walk. So we have this, this has been designed specifically to walk upright without wasting a lot of energy and traveling the environment that we humans do typically and help the humans in doing some of the tasks. As you can see here, we don't have just one, we have actually two of these robots, and these can work in collaboration with each other. Both of them can help each other to do stuff. And maybe if the weight is more than 40 pounds, they can lift it together. So we are working on different use cases and research problems, how we can use these robots and carry out some of the day-to-day life tasks that we would like the robots to do. So this is a fairly new addition to our Ford families, and we are very excited to have these robots with us, and we are looking forward to doing great things with them. Go to the second slide. And one of the key focus for having these robots is actually to help in the package delivery ecosystem. So as you all are very familiar with the convenience of one-click shopping, but you all also know that with the ever faster need for these delivery times to be reduced, and you need packets next day or maybe within few hours, there is a lot of load that is being put on the logistic industry. So for example, US Postal Service alone is handling double the volume that it used to handle a decade ago. It's also taking a huge amount of toll on the men and women who deliver those packages, work in those industry. As you're aware with the current situation, the online shopping has increased even more, and the stress on the overall logistic industry has even grown much more. So here we present Digit working in collaboration with our autonomous vehicle, helping in solving some of these challenging delivery problems. And as you can see here, Digit is equipped with the computer that you guys were just discussing. We write the programs to help the Digit to see the obstacles, climb the stairs, and it also has a hidden advantage that it can actually communicate with the AV, which brings the robot to your door, and use the sensing and compute onboard the AVs to help it do its job more robustly. So together with the help of humans, we envision a world where you will probably get a much more richer experience in terms of getting your packages, getting your goods delivered as soon as possible.
All right, so before we start on the next section of our presentation here, I have a question for you all out in the audience. Digit is a pretty amazing robot, and the plan is to pair Digit with those autonomous vehicles. They will be the future of package delivery, so maybe one day you'll have Digit drop off a package to your door for something that you've ordered online. But like you saw in that video, Digit is able to navigate the world around it. It saw the scooter laying on the ground and it was able to make decisions. Now, if we were to think about our human senses, right? What senses do humans have that help us to navigate our own environment that we might need to equip Digit with for the robot to do the same? So think about senses, right? Oh, someone in Zoom already told us sight, right? So we are obviously always looking around us, looking for obstacles, judging distances of things around us or how we might get to a certain point. That's a great example of a human sense that we might need to think about if we were trying to have these robots navigate a human engineered world. Does anyone have any other contributions? What other senses besides just sight? There's also touch, right? So there's exactly, right? Maybe if Digit were to bump into something, it would be good if Digit had sensors for knowing when he's touching or not touching something. These are senses that humans have as well. Now, we can't exactly put human eyes on a robot, right? But Dr. Pandey is going to tell us next, how exactly do these AVs see?
Yep, that's a good segue to that. Thanks, Anna. And I think we have a pretty intelligent audience today in the group. So yeah, I mean, sense of seeing is one of the most important senses that we leverage. And in the case of robots, we actually need much more than that because our human brains is much more powerful than any computer programs that we have made. So which is also should be obvious to everyone. So for the robots and autonomous vehicles, we use different kinds of sensors. They range from LiDARs, which are also called light detection and ranging, radars, which depends on the radio waves. We use a lot of cameras, which are very similar to our sense of vision, the eyes. And we also use ultrasonic sensors, basically, which send sound waves, very similar to the way bats see. So there are lots of these sensors that the robots and autonomous vehicles use. But today I'll focus on one particular type of sensors. If you can go to the next slide. Uh, this is called LiDAR. And there are different types of these LiDARs that are available today in the market, and lots of new sensors are coming every day. So LiDAR, light detection and ranging, it works on a very simple principle where in the LiDAR itself, you have a laser beam. It is basically a light beam which is shot in the environment. It hits an object, gets reflected, and is received in the photodiode or detected in the photodiode, which is already present in the LiDAR unit itself. There is also a clock which measures the time difference between when the laser was shot and when it was received by the photodiode. And now, since we know this is light beam that we are shining, and everyone knows the speed of light, right? If you don't remember, it's 3 into 10 to the power 8. So once we know the speed, wow, and we know the time, we all also know the formula to find out the distance, right? Which is speed into time. So we can find out what is the distance of the object from the sensor itself. And this is how basically these LiDARs work. And it is very similar to how a bat actually navigates through those dark environments. It sends the sound waves. It keeps a mental clock of how much time the wave is taking to reflect back from any obstacle, and from there estimates a distance. And here in the LiDARs, we do that with a more sophisticated way. So this is how the LiDARs work. And one particular type of LiDAR, which we use, which we have been using in our autonomous vehicles and also in the robot, is made by this company called Velodyne. It is basically a collection of these LiDAR beams. The one I showed you one laser beam in the previous slide, but this particular LiDAR, which is on the left on the AV, has 32 laser beams, which are stacked together, one on top of each other. And they are all shot together. So you get a very rich 3D map of the environment. Similarly, the robot also has a similar LiDAR with a 16 laser beams. So different laser beams are used for different purposes. And together they paint a very nice 3D picture of the environment around us. So at the background, you see that blue points is the kind of the picture that the LiDAR paints for us. And if you go to the next slide, I would probably through this video describe how actually the LiDAR is used. The video is not playing, Anna.
Oh, I can see that. That's, oh, there we go.
Yeah, okay. So if you can pause a little bit here for this video for a moment. Yes, so basically through this video, what I'm trying to describe is how these AVs, with the help of these sensors, are able to navigate through the environment around themselves. So what we are showing here now, and you can run the video, this is basically the first thing that the robot does is in case of autonomous navigation, you have to actually manually drive the robot with all those sensors and make a 3D map or model of the environment. It is very similar to the way we humans do, right? So if I go to a new place, I first make a 3D or make a mental model of the place so that when I go there next time, I know where I am so that I'm not lost. I know, okay, there is a gas station here and I have to take a left turn to reach my destination from the gas station. So in a similar fashion, these AVs and robots, they create these 3D models of the environment, which are pre-stored in the AVs so that next time, as you can see here, when they go to the same environment, with the same sensors, the 3D LiDARs, as you can see here in the red and yellow, is what the vehicle sensors are seeing live. And all the blue stuff is the 3D mental model of the environment that the vehicle has stored in itself, in the computer it has. So once it reaches a location, it matches what it is seeing right now with what it is, what the model suggests, right? So once you match the two, you immediately know where you are in the environment. And once you know where you are in the environment, you can detect what are the obstacles that you need to be avoiding. And based on that, you can decide where you want to go next. So all these sensors along with that 3D map helps you make the decision where you want to go and how you navigate in the complex environment. So that's a very high level overview of how these or robots and autonomous vehicles work in the in these environments. And we hope that we will very soon make all this a reality for you. And very soon you will have a digit uh, delivering a package to your front door, and you can say hi to the digit.
Let's see, let me turn on my camera here. That was really amazing. I learned a lot about LiDAR. Remember everyone that if you have any questions, Dr. Pandey is going to stick around so that we can answer a few more as the program goes on. But before we do that, we have a very exciting announcement that's coming from the Michigan Science Center and Ford about a new exhibit that's launching at the Michigan Science Center this summer. We are reopening to the public on Friday, July 10th. And as soon as guests are back in the building, you will get to see our brand new autonomous vehicle exhibit that was built by Ford engineers. We have some final build photos to share with you today, which is pretty exciting. This is our finished product of our Ford autonomous vehicle. Like we said, this will be live at MySci this summer. It is an interactive exhibit where you can come in, you can sit inside this exhibit to learn more about LiDAR and learn more about how autonomous vehicles are coming to Michigan very, very soon, because they're being worked on right now at this very moment by engineers like Dr. Pandey and all the other teams at Ford. Now, if you can't wait until this summer in order to check out or learn more about some autonomous vehicles, I also have a very exciting thing that you can try at home. Let me go ahead and I'm going to try to spotlight my video here. We are going to talk about an autonomous vehicle that you can actually purchase online and drive around inside your house. These tiny little robots here can really be easily purchased online. They are called Ozobots. And Ozobots are autonomous vehicles. They rely on sensors in order to navigate their environment. But of course, you as the programmer are going to have to learn how to code these Ozobots. Just like we talked about with Digit, these have some very special sensors on the bottom of them. Ozobots specifically rely on light sensors so that they can read different types of color codes. I have a diagram to share with you. These are some basic color codes that are read by Ozobots as they drive around on the surfaces of paper or even a tablet if you were to download their program online. Of course, we have our Ozobot here to show you just some of the capabilities of these Ozobots, because just like we discussed in our 3D printing episode of Echo Live, these kinds of technologies, as engineers work on them and they become more and more attainable, we are able to find these amazing kinds of technologies in stores, online, and even bring them into our own home. So this is the actual robot itself. And on the very bottom is a light sensor. What an Ozobot will do is on black colored lines, they will actually drive around on the surface of your paper. So if we go ahead and power it on and let it go, you'll see that it knows to follow that black line that I've drawn with a marker. But just like you saw in that coding sheet, we can also add in special codes. This one's called the tornado. So it did a quick spin, and then it should make it to the very end of our Ozobot track here. And it should do just a little dance for us as it celebrates making it all the way to the end of the maze. Now, when you're learning to code with Ozobots, you can draw your own paths, but if you're looking to get started, you can also download patterns that you can find online, like this one. So there are pre-built codes. This one is a maze that programs the robot to do some different kinds of commands. So there we go. We have our tornado code again. It knows to get to the end of the road and turn around. But again, these are codes that you can write. This is an autonomous vehicle, although it might not be great for package delivery like Digit or the Ford vans might be. This is a great way to practice communicating with robots because this really is the future. It wasn't too long ago that we thought autonomous vehicles and robots were only the stuff of science fiction movies like Star Wars and our R2-D2 clone here, but we know now that these technologies are in the world all around us. And if we're going to continue using them, it's great to get familiar with these kinds of things. Now let's go ahead and let's check on our chat here. Someone had a question, Dr. Pandey, about Digit. Their question was, do you ever put clothes on it?
That's a great question. We surely can put clothes on it. Nobody is stopping us, but generally we try to manufacture the outer cover that we have designed in different colors. I think the agility manufacturers, they build it in green, blue, all sorts of colors. So you can actually paint it with different colors to get a different look. So yeah, I mean, but if you want to dress him up with a shirt, I think that should be possible.
Yeah, why not? Someone else asked, what about how can Digit interact with living things like dogs? What if it were to come in contact with a dog?
Yeah, so that's a very interesting and good question. So it's all about teaching the robot what to do in what situations, right? So as you were discussing earlier, you will have to write the code to program the robots to behave in certain ways around certain people. So machine intelligence or artificial intelligence, we are already working on that so that the robot can actually learn to behave differently with different people, animals, and so on. But we are still a bit far away from that, reaching that point where you can just throw the robot out in the wild and it will figure out what to do. I think that's not, it will happen anytime soon. But for now, the way we do it, we basically program a set of rules and robot and our vehicle just follows those set of rules. I mean, very similar to the way we drive the vehicle, right? We follow the rules. If there is a stop sign, we stop. And that's what we write the code in the vehicle, for example. If there is a stop sign, vehicle detects the stop sign and stops. So coming back to the question, how it will behave with the dog, I mean, we can program it to be very gentle and maybe pat the dog. I don't know. But for now, I think the goal will be to not basically avoid hitting anything, right? So just safely get out of the way of the dog and let it go.
That sounds like the best answer. Someone else asked, does the size of the robot affect its vision or its ability to have vision?
So that's again a very good question. So the size of the robot actually does not matter here because all these sensors we put on top of the robot. So we can just put them anywhere, and we typically find spaces within the robot body, or for that matter, the body of the vehicle, so that it can see whatever it needs to see. So for example, in the case of the robot, we actually have a camera on the head. We have a camera on the chest. You also seen a LiDAR on the head. And then there are cameras on the back. So there are lots of cameras all around the robot, which it can use to see. So size of the robot typically does not affect that much, as long as you put the sensors in the right place.
Awesome. Someone on Facebook asked, does Digit have a motherboard? And maybe you want to talk about what a motherboard is or whether it does or does not have one.
Sure, yeah. So, I mean, motherboard is basically a computer chip, which you have in your laptops or in your desktop computers, right? Every computer has a motherboard, which consists of the CPU, the central processing unit of your computer, memory, and all the other different kind of connections that you need. So yes, I mean, basically the digit has a computer of its own in its back, which is powered by the batteries which are already there in the robot. And those batteries are also very similar to the batteries you have in your laptops, which could be recharged once they are discharged. So yes, they have a mother, they basically have a full computer for that matter, which is used for making all those decisions, making sense of all the data that is coming from all these different sensors and so on.
All right, we have another great question, which I'm curious about as well. What if Digit does stumble and fall? Is it programmed to be able to get back up?
Yes, and unfortunately, I don't have the videos of that, but I mean, that's where his hands actually help. So we have done these experiments, and that's how it is designed, so that if it falls, it uses its hands to get back up. So it can actually get back up in case it falls.
That's a great question, because I think we all wonder that. Robots aren't perfect, right? They're still learning. And so, of course, what if it did trip over a dog? It might need to get back up one day.
Yep.
Very cool. If you still have questions, continue typing them in the chat. We've had some really great ones so far. I'm just about out of questions, but we'll stick around for just one more minute while we wait for your last questions. I would like to, of course, at this time, we always take a moment at the end of our programs to thank the sponsors of Echo Live, like Ford Motor Company, where Dr. Pandey works, and Denso. They've allowed us to bring these programs to you for free every weekday since quarantine started. We are very excited that we will be reopening to the public on July 10th. That's coming up very soon. And we also have registration links live for our virtual summer camps. And you can even win a free week of MySci Virtual Spark Camp by filling out our Echo Live feedback survey. You can tell us your favorite episode. You can tell us things that you'd like to talk about in the future. Remember that if you fill out that survey by today, you will be entered for a chance to win, and we will be announcing the winner on Monday. Right here on Echo Live, you'll find out if you won that free week of camp. Even if you don't, you should definitely still sign up, because it's going to be really cool. We'll have lots of talks from experts like Dr. Pandey and from other Michigan Science Center presenters as well. So I don't see any last questions in the comments, but thank you so much, Dr. Pandey, for joining us. This was really cool and really informative, and we hope we'll see you back here very soon.
Thank you. And I enjoyed it a lot. Thanks a lot for all the good questions.
You're welcome. Bye, everybody. We'll see you next time.
Bye-bye.